Let's begin. Today's November 27th, 2024, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses the following 5 criteria cards. Criteria card 2, 9, 13, 16, and 20. And the puzzle uses the blue verification cards. The code above is your way to get more information on today's puzzle by searching the code on turingmachine.info. Let's go solve. So in the grid above, we've got our 5 criteria cards. On the top row, we've got criteria card A, criteria card B, and criteria card C. On the bottom row, we've got criteria card D, and finally criteria card E. So criteria card A takes a look at our first digit, the triangle digit, and the Turing Machine will compare it to the number 3. So should the value of triangle be less than 3? Should it be equal to 3? Or should the value of triangle be greater than 3? Criteria card B takes a look at the 3-digit solution, and the Turing Machine will let us know how many 3s there are. Are there no 3s? Is there a single 3? Perhaps 2? Maybe even all 3 are 3. Criteria card C will take a look at our middle and last digits, square and circle, and compare them. So should the value of square be less than circle? Should they be equal? Or should the value of square be greater than circle? Criteria card D again takes a look at our 3-digit solution, but this time it'll let us know a little bit about the ratio of even to odds. Should there be more even than odds, or should there be less even than odds? And finally, criteria card E again takes a look at our 3-digit solution, except this time it'll let us know a little bit about its structure, so to speak. Specifically, it can tell us whether there are no repetitions in our code, as in the example 125, or it could inform us that it's a double number, where there's a digit repeating, as in the example 112, or it could even tell us it's a triple number, a single digit repeated 3 times, as in the example 222. And remember, the objective of today's puzzle is to find that unique 3-digit code that abides by all of the 5 criteria cards we just described. And we're going to start off with an initial proposal of 314. So I think the first thing I'd like to test is criteria card D. Okay, so the Turing Machine does not approve of my choice in proposal 314. And recall that criteria card D will let us know something about the ratio of even to odds. Since I do have 2 odds to a single even, and the Turing Machine does not approve of that, it's actually informing us that there actually should be more even than odds. So let's go ahead and type that up in our notes in section D. And we'll say that there are more even than odds. Now, it could be that we're dealing with an all even solution, but we could have, we know that we have to have at least a minimum of 2 evens. So that means you could have a single odd. And let's see, let's go ahead and test criteria card E. Okay, so the Turing Machine does approve of the proposal 314 in that, 314 has no duplicates. So it's informing us that the solution has no repetitions. So let's go ahead and type that up in our notes in section E, and we'll say that the solution has no repetitions. And since it has no repetitions, together with the result of criteria card D, we can actually conclude that because we have a majority of evens, that means, and they're unique, that means we are looking for a solution that is that includes a 2, a 4, and an odd. Now, of course, we don't know the order of how they appear in our solution, but because of the majority of evens and no repetitions, we know those evens do not repeat. So they have to be a 2 and a 4. And because of no repetition, that 3rd digit must actually be an odd. Now we do have criteria card B letting us know how many 3s there are. Well, at this point, it's either there or it's not. So if it's there, fantastic, it's a 3. If not, then it would point either a 1 or a 5 for the odd value. And so looking at now criteria card A and C, well, we know we can't have equals. So we know because they're all distinct. So it really now boils down to being a 50-50. And so, yeah, let's go ahead and test criteria card C. Okay, so it does approve, and we are comparing the middle and the last digits. So it does agree that, well, at least in my proposal, I have an odd 1 in square and an even 4. And because the Turing Machine agrees with that, it is true that square should be smaller than circle. So let's go ahead and type that up in our notes for section C. And again, we'll say that square should be less than circle. And I think we finally will be able to cross out some numbers. So let's see, what must be true? Well, if square is to be smaller than circle, I don't believe square could be 5, because if square were 5, I don't believe there would be anything larger for circle to be. In a similar fashion, I don't believe circle could be 1, because if circle were 1, there's nothing smaller for square to be. So we're just crossing out those 2 endpoints. And let's see. Yeah, it looks like it's pretty wide open. I don't think we can really cross out anything at all. Okay, well, that does it for this round. We did complete our 3 Turing tests. We're now going into the phase where we'll be discussing how to construct a good second round proposal. So the only things that we did not test were criteria card A, where we're comparing triangle to the number 3, and whether there is in fact a 3 or not, whether our odd is a 3-digit. So it could be as simple as, yeah, triangle's a 3, there is a single 3, and because we know square and circle would be our evens, yeah, that would mean that a square would have to be a 2, and then circle would be a 4. It could be as simple as that. That's if our first digit is an odd 3. Is there any? I think that's the not most logical, but the most obvious of possibilities. Because if triangle were the odd and it's not 3, then how would you pick between 1 and 5? You're not really comparing triangle with any of the other digits. Could it be less than 3 or greater than 3? Well, I guess it could, but again, you'd fall under, well, is it odd or even, right? Is it a 1 or a 2 versus a 4 and a 5? So we just don't know that. Let's see, what else? Yeah, I'm not sure. The only thing we can, well, no, I was going to say, if it's not a 3, if triangle's not a 3, we can't just conclude it's even, unless we also test B. So, well, nothing's really coming to mind, so I'm just going to pick that 3, 2, 4 proposal. So let's go ahead and try that out. Okay. All right, yeah. Well, let's see. Let's go ahead and test criteria card B first. We know, if there's a 3, great. If not, we know it's going to be a 1 or a 5. So let's go ahead and test B. Okay, so there is a single 3-digit. Let's go ahead and type that up in our notes for section B, and we'll say that the solution has a single 3-digit. And since we have established that odd to be 3, that means we can go ahead and cross out all the 1s and 5s that are remaining. So okay, and then finally the circle 5. Okay, and I believe if A gives us a check mark, yeah, we found our solution. Let's see, can we deduce it? Let's play a little bit of a mental exercise. What if square were 3? Now, I have no basis for picking that, but if it were, then we would know, what would we know? That circle would be forced into a 4. So that would mean that triangle would have to be less than. I mean, that's plausible, right? The only thing that's left to pick for something that's less than 3 would be a 2. But, okay, if that were a 2, let's just say, let's play that game. Triangle is less than 3, it's a 2. Yeah, I guess it would have to force square to be 3 and then circle 4, because we know square has to be smaller than circle. Yeah, you are sort of forced into that. Okay. If it's a 3, then again it's going to be 2, 4. What if it's greater? If triangle were 4 or greater than 3, 4, that would lead to, let's see, well, would it? If that's a 4, yeah, that would force square to be 2 and then circle to be 3. Yeah, there are a lot of possibilities, actually. Well, let's go ahead and just test A and see where we're at. Okay, wow, so it is not 3. Okay, so let's go ahead. Well, let's actually write in our notes. We don't know what it is. All we know is that it has to be either less than or greater than 3. So we can cross out triangle 3. Okay, well, the good thing is that we've established that triangle is even. We know that much. So let's see. We may just have to write out some answer choices. Well, I think at this point, because we don't know what triangle might be, yeah, I think we have to retest it. Well, let's see if we can list some possibilities. So, well, let's pretend that square is 3. So if square is 3 and square is to be smaller than circle, then yeah, it looks like 2, 3, 4 is a possible answer choice. And obviously it would coincide with triangle having to be less than 3. Okay, yeah, that's if square is 3. If circle is 3, that would force square to be 2 and then triangle to be 4. So it looks like it would be 4, 2, 3. And I think those are the only 2 answer choices. So yeah, 2, 3, 4, and yeah, because there are no duplicates. 3, 4. Yeah, 2, 3, 4. And then 4, 2, 3. Okay. Well, let's see. Is there any indication that somehow we can deduce? There's nothing that says anything about ordering. So, of course, it could be increasing or it could have no order. Yeah, we've got 2 evens and a single odd, and it is 3. Yeah, I don't see anything one way or the other where we could deduce the solution. I think we just have to test it one more time, and unfortunately we'll have to go to a third round, forfeiting our third test. That's not good when we're competing against the Turing machine. So let's see. Yeah, I just don't see any way around it. 4, 2, 3, 2, 3, 4. Yeah, I don't see it. Okay, well, again, we're going to have to go to a third round. And between 2, 3, 4 and 4, 2, 3, I'm just going to pick 2, 3, 4. And so we are going to test criteria card A again. So let's go ahead and test A. Yeah, because that will tell us which one it is. Okay, yeah, so it does like, I did choose 2. 2 is less than 3. So it liked that. So let's go ahead and cross out the greater. And let's cross out the 4, 2, 3. And so, yeah, let's go ahead and now cross out the 4 in triangle, establishing square as 3. And that would mean that circle is 4. And so, yeah, it looks like our 2, 3, 4 is our answer choice. And I will reveal why did I pick 2, 3, 4 versus the other option. And that's because if you play enough of these puzzles, one thing that you'll observe is there are quite a few rare solutions that are either increasing or decreasing. And so I'm thinking, well, maybe this puzzle, since there is no ordering, it may default to one of those options that are not a no order. But that's just coincidence. That's just, my gut feeling. Well, let's go verify. So let's test 2, 3, 4. 2, 3, 4. Okay, fantastic. Well, how did we do versus a Turing machine? Well, it is a 5 criteria card puzzle, but we did 6 tests in 3 rounds. Not the most efficient. So let's see. We did do C, D, E in the first round, and then we did the remaining 2, A, B, in the second, and had to retest A. Okay, so let's go check it out. So C, D, E in the first round. So C was correct. D was incorrect. E was correct. I believe A was incorrect. B was correct. And then we retested A. Wow! Totally surprised. So yeah, we both went to 3 rounds, but we only had to do 6 tests, and the Turing machine did it in 7. So we still beat it by 1 question. Wow. I guess in retrospect, maybe, yeah, we should have tested A in the first round. But what would we had to give up? If I had to guess, I probably would not have tested C, just because criteria cards D and E were a great combination where we established the fact that we had a 2, a 4, and an odd. Would that have been better or worse? I'm not sure, but I'm just grateful of getting the win by one question. Well, what about you? How did you play this puzzle? What criteria cards did you choose, and did you discover anything interesting that you'd like to share? Add those thoughts to the comments. If you liked the video, please do give it a thumbs up so that more people can find the channel. And of course, don't forget to hit subscribe to be notified of the next video. Well, until next time, have a great one.